So we decided not to Ah, oh, you had it on a slide already, or? Yes. Okay. Okay, good afternoon. This is the Thinking Research Group summary meeting. I'm Carsten Bormann. Beside me is and I'm going to mute the microphone. And beside me is Ali Kevin. It's Thursday afternoon. This is our Nodeware slide. Sheets will be going around. We have note takers. There is a Jabber group. Did we find someone who joins that for us? Okay. And of course, there is a mailing list. And most importantly, there is a GitHub repository for every meeting of the research group in any form. We have a GitHub repository. So in the T2TRG organization, that's this time 2018-IETF 102. And there you find pointers to slides and to the note taker etherpad and things like that. So who's doing the Jabber thing? I'm not sure that we will need that, but it would be good to have it. Anybody here can use Jabber? Thank you. Okay, so the agenda is essentially two parts. I'm doing the introduction right now. We will have a few updates of various activities within the research group and from activities outside the research group that are of interest to us. And then we will go into one segment, next steps in security, and wrap up and hopefully end by 5:50. So what is this next step in security thing? We asked a number of people to give a quick personal point of view of what we should be doing next, where we might be the IETF or the research community that is interested in IoT security in general. What are things that we should be doing? And again, this is a personal point of view. And the idea is that we might be getting a little bit discussion that helps us guide our further work here. So we have 1 hour for 5 talks, and we will see how we manage the time. But there should be enough time for discussion after each of the talks. Just to remind you what the Think2Think Research Group is, who has not yet seen this slide? Okay. So I think I can do this quickly. The IETF has been generating all these wonderful specifications. And how do you actually make a real IoT work?
Oh, I just wanted to raise my hand because I think some of the topics that I have debated folks about is that should we just be focusing on constrained nodes given the disruption with edge computing and that there's more stuff in the network that may require not only constrained nodes, but additionally nodes that are connection points or aggregating nodes. So that might be a
have
debate.
a slide for that in a couple of minutes. I think that's a really important point. Okay, so what did we do recently? We have an activity that we call WISHI because it can be said faster than Think2Think Research Group. And WISHI stands for Work on IoT Semantic Hypermedia Interoperability, which again is a little bit of a mouthful. But the idea is that we have a lot of convergence in the lower layers right now, but at the application layer, in particular at the level of semantics of the messages that we are sending around and of the data that we are sending around, different standards organizations still do very different things. So how do we get semantic interoperability? How do we get a lightweight end-to-end switch to controlling OCF light? How do we get sensors from different ecosystems to contribute to a common sensor database? And we have been working on this, first of all, by calls which were meant to be approximately bi-weekly, but of course then there's always one that doesn't happen. And we had a hackathon that we will hear more from in a minute at the weekend leading to this IETF. The document State of the Art and Challenges for the IoT Security is ready for publication and is going through the bureaucracy. As we would say in Germany, it's taking its socialist course. Well, it will probably take another month or so until we can push it into the RFC editor queue. We have been working with other SDOs, and one of these is the OCF, the Open Connectivity Foundation, that has a pretty comprehensive set of specifications that are based in large parts on CoAP and CBOR. So it makes sense to talk, to discuss current challenges with them, to discuss how we should be developing documents and so on. This is a little bit on the edge between research and engineering. It's actually on the edge between these two and consulting a little bit as well. But I think the research group is still a good place to actually run activities of this kind. And we have been doing this with OCF for a while. We have a pretty close relationship with W3C, and we will be expanding this with OMA SpecWorks as well, the people who run lightweight M2M and have also taken over the IPSO vocabulary. And we had our first joint meeting, I have no idea what day, yesterday or today? This week, yeah, you know what an IETF does for you. So I think it was yesterday. Yeah, I don't know yet how that will go on, but we have the best intentions and we think we can pull this off.
Just a quick question on the previous slide. Do we have any information from Alison on when this security draft would move forward? Or is there something that still needs to be done?
Well, she told me that there is a slight level of coordination within the ISG that is habitually performed before she can press the button for that. And that coordination was still ongoing when I last talked to her. But the point is she will be pressing this button very soon. Okay, so one interesting thing we should be doing as a research group is identifying research topics. And I just pulled out 3 topics out of a few more that we had the impression that it would be good to work on when we had our hackathon and other activities this week. Some of these are pretty pedestrian, which doesn't change the fact that it's not something where you just sit down and engineer. You have to think about the problem and maybe try something and measure something before you have found the right answer. And one of these, for instance, is given that we now have pretty good ways to describe our data models, the next question is, how do we get all this legacy information that is in some binary blobs from Modbus and BACnet and whatever, and get these data over into the data model level that we enjoy with formats like JSON and CBOR? And how can we do this in a way that it's maintainable and people can write specifications? So it's kind of like what we do with formats like CDDL, but lower at the level of bits and bytes. So, of course, people have done something like that. For instance, there is an activity, of course, I forget the name, that's named like ASN1, but slightly different, that does this with a C-inspired mechanism. But again, it's maybe time to re-examine this and see what is the 2018 answer to this. The second thing we noticed is light bulbs usually make people smirk a little bit, but when you actually look much closer, there are some non-trivial issues around controlling and monitoring lighting. So maybe this is something that most of us think we understand, but we can generate a good work example for describing actions and properties and events and so on around something that is seems to be trivial, but in reality isn't. So that would be something that is some effort writing things up and completing it. Maybe not a classical research paper, but something that a research group might be good in generating. And the third thing we noticed is we have this large set of description techniques out there, but it's not always clear how these description techniques handle protocol evolution. So how do you describe something that's changing? So yesterday when we talked about the IPSO data model, we started discussing, oh, there might be different versions of that IPSO data model, and how does that work? So right now, their description technique does not enable describing that evolution, and that's not a problem that is unique to IPSO, to the IPSO models. We need to understand protocol evolution, and we need to enable it as much as possible, because the world around us does change. Okay, so these are three examples for activities we might be picking up, but of course, prerequisite for that is that we have people who are interested in this. So let's.
Hi, Carsten, thank you. So Robin Wilton, looking at your second one there, semantics of state of and operations on a light. I think you're absolutely right. These things may seem simple, but when you work them through, they really aren't. That example in particular resonates with me because I often use that as an example when talking about the privacy implications of IoT. And the reason I use it as an example is our mental model for what a light does is that the user interface is binary. It's either on or off. Okay, with smart light bulbs, you may be able to change brightness and hue, but those are kind of nice to have. But the meta issue this raises about privacy in IoT is the gap between what the user interface exposes in terms of data and the data that is actually being used. So what you've described is the stuff that is not accessible or visible to the user is actually much more complicated than that user's model of what is happening. And I think there's a privacy gap there which can give rise to the opportunity for things to happen that the user did not legitimately expect. So I don't know if it would work as a security consideration as part of that research, but I think that would be a really good adjunct to it.
Thank you. Well, that's very good input. I think we often will have the situation that there are privacy considerations attached to some ideas and some models and so on that you don't immediately see. Peter.
Peter van der Stok, a clarifying question, please. How formal do you want these models to be? Do you think of a UML model with all the byte strings in, or do you think of a VDL specification where you can do some cross verifications? I'm a bit lost here.
I have no idea what we want there. We want to learn as much as possible from it. And if a funnel model helps us learn more, then we should do a funnel model.
Okay.
Usually writing text is more work than doing funnel work, at least for some people. So let's see, but that's a good question. Okay. So the first step would be just to go ahead and collect which description techniques are actually applicable. So is this a W3C thing description that we are using? Or?
But you want added value with respect to what there is. So it would be nice to know what the added value is, and then you may actually decide on what kind of language is the best. Okay.
Thank you. Okay, so let's quickly talk about next meetings. We will continue these wishing calls probably now in the summer period. They will be more like monthly. We will continue our virtual meetings with OCF and possibly have another face-to-face. We will start having virtual meetings with OMA SpecWorks, the people known for lightweight increment and IPSO. And yeah, at the next IETF, we probably will have some activities, and one of them might be a next round of the Rishi Hackathon, but another one might be to go a little bit outside the box and talk about things that are sometimes called edge computing or in-network computing. So I have a slide on that in a minute. That will probably be the last major activity this year. And then, of course, 2019 is coming up, and we want to again co-locate with academic conferences. So like the workshop we had at NDSS at the beginning of this year. So that requires a little bit of planning ahead. If you have any idea for a venue which would be good to get some progress, we definitely would like to hear about it. So let's talk about edge and in-network computing. So the general observation is that much of the computing has moved to data centers these days, but this is not necessarily appropriate for all kinds of computing that we want to do. So people are working about locating computing resources at the edge, near the devices, which in our case would be IoT devices, and in the network in some form. Those people who already have a little bit of gray hair will remember active networking in the 90s, so that was a form of in-network computing, but it wasn't particularly successful. And there maybe are reasons for that, in this round we can avoid. So that's an interesting question. How do you do this in a way that's actually successful? Yesterday we had an IRSG dinner, and it looked like at least 4 of the research groups of the IETF have a stake in this in one form or another. So the thing-to-thing research group wants this because we are a customer. We have IoT devices, and those devices don't want to do all their computing by themselves. The ICEnergy has models for doing in-network computing and for finding computing resources by name. The DINERGY has ideas how to provide a decentralized infrastructure, which is exactly what this is, and provide, for instance, consensus for that. I'm trying not to say the word blockchain, because it may be a different form of consensus. And finally, a new research group is being proposed, the privacy analysis research group. I forget what the E was for. And all these things, of course, have a privacy implication, which is not trivial because these networks will be multi-stakeholder networks. You have to make sure you understand what you're doing. So, and one recent submission, for instance, we have had several before, the draft from IoT edge computing, which you might want to have a look at. This is an example for the interest that's in this environment. And we actually had a session about edge computing in IETF 100. So maybe we can put something together for Bangkok. And if you're interested in this subject, please talk to the chairs, and not only these chairs, but also the chairs of ICEnergy and DINERGY and not sure if TRG is here. Oh, Dr. Richards. Okay, we have a few documents in the research group, and we already talked about the state of the art and changes for the IoT security. So this is, from the point of view of the research group, done. We just have to exercise the bureaucracy around the research group. We have a document called RESTful Design for IoT, and we have several documents that are not quite in the shape we want to have them, but make pretty good material for new documents. So we have, for instance, Coral and Core Apps, several documents that might be follow-ons to the RESTful Design document, but we also have the Internet Web Coexistence in IoT document. We had an extremely crowded site meeting in Prague about that, so there's a lot of interest in that. So let's see how we move these ones forward. So do you quickly want to say something about RESTful Design?
Okay, so the other research group node that we have active right now, the RESTful Design for IoT, was a bit slower progress for a while. The authors were contemplating what's the right way forward there, what kind of things want to include there. However, there was one update before this IETF, was this adding the 0.1 version with the hypermedia guidance, so that it's good to use forms and links to build your application and use the other hypermedia functionality. However, now more recently, we did quite a few updates on the version in the GitHub. So there are a lot of IoT specific throughout the draft. One comment that we got is that while the document had a lot of REST specific, somehow it wouldn't have that much IoT. So now we add quite a bit of information on that. For example, on the role of REST constraints. So this is related to the comments from Mike Amundsen a while ago, that there are different constraints applied to different extent, perhaps in IoT scenarios. There's some information about that. And then also on some system characteristics that are more IoT specific. For example, that in case of REST and IoT, we're using REST not only to scale up and out, but also scaling down, being able to contemplate also for very constrained devices. And also this need for evolution, that you cannot necessarily update all your devices at the same time, even though you want to have evolution in your system. So how can the REST principles help in that kind of case? And also we updated the terminal section. We noticed that this being able to dereference URIs and having URIs that can do that wasn't very well explained yet. So now it's part of the draft, and also using the dev URN URIs as an example of such URIs. The next steps, so there was quite a bit of progress on the draft, just up until today even. Our goal now is to do one more review of internal consistency, have the final things in the draft. But you are very welcome to review the draft already. Just go to GitHub and check out the latest version in the master branch. Then also, as Carsten mentioned, the core abstract is something that we're planning to revive, because we reviewed that again. One idea was to bring contents of that draft as part of the RESTful Design draft. However, there was so much good material that maybe it makes a lot of sense to have it as a standalone and just a reference from here. So that's one of the ideas what we're planning to go forward with the RESTful Design. And when we get these things reviewed, organized, the idea is to submit a new version and also get a bit broader review. So for example, Mark Nottingham pointed out that we could get from microservices community, for example, to review this draft. That's the way forward.
Thank you. So there is one more document that has been around much longer than this research group, which is the security bootstrapping document. I think that started out as a 6-year plan document. It's almost 10 years ago when that started. So the idea was to generate a survey of security bootstrapping methods. And I think this is a useful document, but it's not quite clear to me how to develop this in the research group. So people have read this, but then haven't commented about this. We have very little feedback. So it's not quite clear to me that we have the energy to evolve this as a research group document. Here.
Carrie Lynn, I'd be interested to know whether there's commonality between this proposal and secure update of IoT devices. Is there some common ground there?
I think these are pretty clearly separate, but maybe other people have other ideas about this. So secure update is now already in the review status. We have the secure update in Internet of Things working group or suit. So this is not something that we as a research group have to do a lot for at the moment. I don't think the chairs need an answer now, but if you are interested in moving this document forward and adopting it as a research group document and providing reviews or even maybe providing additional material for it because it's not complete, it's not exhaustive, then please talk to the chairs. Okay, with that, we are in the actual agenda. We're about 20 minutes late. And Michael will start with a report from Rishi. And thank you.
That's the don't push that button. Again. Okay. So Rishi is, as Carson said, the work on IoT semantic and hypermedia interoperability. We have had roughly biweekly teleconferences between IETF meetings, and we have semantic and interoperability hands-on testing and more recently some breakout sessions at the IETF hackathons, the last 3 hackathons. Some of the topics that we've been covering in the meetings are related to planning for the hackathons as well as exploring the general space around requirements and some various solutions and components for this activity. We make a lot of use of the W3C tools because there's a similar focus and mission there. We've looked at processing models for semantic data and how we process semantic data. Terminology for different layers of the system, so when we write documents, we can have some common grounding terms that we use. How to integrate IoT with energy systems, and that was an interesting presentation from Bruce Nordman of LLNL, Lawrence Livermore National Labs, doing a lot of smart building and building energy work in California. Also, I looked at JSON LD 1.1, which is the new version of JSON LD that allows much more flexibility and processing for file formats, and we're applying that to thing description. W3C Plugfest and Rishi, those are 2 activities that have some common, a lot of common overlap, and so we looked at how those 2 relate. And we recently looked at how we apply IoTschema.org to IPSO and lightweight M2M models. And we've recently working with other SVOs. A lot of this is repeating what Carsten just said. We're working with OCF, OMA lightweight M2M. At the previous Plugfest, we had some work with Geneva VSS, which is an automotive specification that talks about how you interact with different in-vehicle information systems. And of course, Web of Things and IoTschema.org. And what I have for the rest of this is a little bit of a description of what those last 2 things are. Thing description. Thing description is a file format and an RDF media type that describes the abstract interactions with things, such as how do I read temperature, lock the door, change the brightness of a light, and binds those to concrete instances of things that implement those interactions. So it defines the payload structure, the URI, what the address is, where you go, how you operate the transfer layer, and then what the data characteristics look like coming back. And so using thing description, applications can use the abstract interactions to sort of start decoupling from the underlying implementations and start providing an abstract interaction application layer. And ultimately, we want to be able to automatically adapt to all of the specifics of the device protocols and data formats. We only need to deal with the high-level interaction models. IoTschema.org is an external vocabulary that we use to annotate instances of thing descriptions or other general hypermedia controls, metadata. Can be used really in any metadata framework. We have some high-level semantic categories to annotate systems at different layers. We can annotate high-level capabilities. We can annotate interactions. And we can annotate data items themselves. So that provides a bit of a decoupling from the control plane, between the control plane and data plane, as some like to call it. That allows you to consume data, if that's what you're doing, and analyzing, or interact with things and understand the data if that's what you're doing. And the way all those work together is essentially in description, the semantic annotation and the interaction model sort of lets you describe what you want to do in an abstract way. And then the protocol bindings describe how that's done in a concrete way. And those bind to specific device protocols like OCF and IPSO and, you know, ... et cetera, things that we might be seeing in the future. So this weekend we had a hackathon, and we wanted to, basically what we do is we test the interoperability mechanisms in a real system. We bring hardware and some Link simulators. We try to operate across the teams and across the contributors. So I'll try to operate some device that someone else brought, and someone else may have an application that tries to interoperate with the device that I brought. We learn about where the gaps are, and we identify new requirements, and we test some new extensions and patterns that come out in these systems, like thing description. And then we have breakout discussions to explore issues. So basically, this is just an idea of what the kind of system roles we have, and mostly there's things in applications, but there are also bridges that can bridge to these other ecosystems, like lightweight M2M. So directories that we use to discover and find things, proxies that we use to rehost things, and that's really especially good for traversing NATs and firewalls. And we have this idea of a local area network and the broader network of the internet, and we sort of try to interoperate between the internet and local network too. And W3C provides a number of components. There's some color, you can see the color. So there are a couple of components, node ROT and thing directory, that can be used to fulfill those roles. But other components can be used in those roles as well. And this gives us an idea of what we've been working with in terms of the different formats and media types. And of course, fundamental is web linking and core link format, the Web of Things thing description, ONA, SNML, JSON. We use protocols HTTP, CoAP, and MQTT, and we're looking at integrating, how do we integrate DNSSD into the local discovery environment as well. Additionally, we have the software components that we're using, node ROT, thing directory, core resource directory, which can also be used as a directory in this. Node Web for application, for quick prototyping of applications, turns out to be a really handy tool, and also allows you to interface directly with CoAP, HTTP, and MQTT. And then some of the bridged ecosystems, OCF and lightweight M2M. IPSO, also specifically, we're looking at IKEA TradFree, which uses CoAP DTLS, and Philips Hue, which is a sort of a LAN HTTP kind of system. And these are just bridges that control light bulbs. And the projects that we had in the hackathon are basically looking at how do we map IPSO and lightweight M2M to abstract models using thing description and IoT schema. How do we map OCF the same way? How can we build an RD, a core resource directory implementation that can be used for semantic lookup and higher layers than just the current RD? We've proven out the Web of Things protocol bindings to CoAP and DTLS, so now we can basically have a thing description in Node-ROT that can talk directly to a device that exposes CoAP and DTLS and do the security handshake automatically and do the transactions automatically just based on the thing description. And we're starting to work on semantic wrappers for the scripting API so that the application can be even more decoupled. And we're, again, the DNSSD integration. For some of the results, we did have a good breakout discussion, and we have some topics collected from that. We did demonstrate interoperation between clients and different devices. We disclosed 44 issues with Node-ROT and moved that over to Eclipse Foundation. So now if you want to use Node-ROT, you go to Eclipse, you clone the repo, you build it, and it works. And so that's basically practically in production now, you might say. We got the RD, Carson got the RD implementation up to speed, and we're ready to start building out a thing directory based on RD. And again, I say this again because it's so cool, we just automatically interoperate with CoAP, DTLS, do the handshake and everything. And we're working on a report for that. So the breakout topics were sort of, again, how do we attach models to existing instances of descriptive data? So this is sort of like the thing description problem, but a little more generic than that. What are the general issues, use cases for doing that? The topic of shared models across device ecosystems, how can we build some shared models that work well for different targets? High-level semantic API, I mentioned that. This is the idea of not needing to use the addresses, but being able to operate devices based on their semantics only. We worked on mapping thing description to core loop format. We had some more work on discovery and what do we want to do for that. And then in general, let's talk some more about how and where we use semantic interoperability. Peter van der Stok, a clarifying question about discovery use cases and scenarios. Does the discovery use cases and scenarios, does it imply the security aspects?
There are a lot of questions about security. I think Carsten had a bullet point, security of semantics and semantics of security. This would be the security of semantics, if you will, or how do you who's allowed to discover what?
Okay, fine.
Yeah, that is definitely part of the workspace here. Okay, so what we learned is we actually have a fairly complete tool set, and we don't really need to build a lot of infrastructure. We need to start building out uses and applications on it. And of course, there's still some gaps, but we pretty much have an end-to-end thing that we can start working with. We need to start thinking more about some of the high-level applications and test cases, including security and how we do end-to-end protection of some of these things. We might start thinking about modeling internal behavior of things, and so we send a command to something and we get a response, but what does that really mean? If I'm an IoT application, I might want to know a little bit more about what I'm actually doing. And then logistically, we found that there's still a big issue with setup time. We need to figure out how to streamline things and get everything going. But it might be that this next bullet is if we can figure out how to do distributed testing and enable virtual NANs, F-interop type system, then that might have us in a better state of readiness. And then we need some alternate implementations of the critical functions. We need multiple directories and multiple sort of server implementations that we can use. So that was the end. That's all on the hackathon. Are there any comments from others who were at the hackathon or anything anyone wants to add? Okay. IoTschema.org, this is quick. Basically, we've had about 1 year of experience with this since the Wishy workshop. We're validating the basic categories and the annotation style by using thing description. We've been using it in several Plugfests and Wishy hackathons. There are 20 or 30 experimental definitions in progress, and we've added lately this feature of interest pattern so we can connect what the things do, like light bulbs, to the physical world, like what location and equipment, where they are, and what they actually act on in the physical world.
Here's an example of semantic annotation, and not terribly self-explanatory, but it shows that we first define a vocabulary and a namespace, and then we use terms in that namespace to annotate different things, and this shows the capability, the interaction, and the data that I mentioned earlier. This is our model. It's not much of a model. It's pretty simple. It just shows that you can have capabilities, interactions, and data items, and we have a few classes of interactions. Feature of interest connects to those. So looking in the real world, it's a location or equipment can be a property or action that would be associated with different actuators and sensors. And in the roadmap, we're working on a process so that we can have some community contributions coming in, building up some introductory materials to help people get started, and tools, and building out the feature of interest stuff as well. And we have a monthly community teleconference.
Okay, let's catch up some time. So this is an update from the W3C Web of Things activity. So there's an interest group and a working group there. Just a summary, what this work is about. So in general, it's about countering the fragmentation in the IoT so that it becomes easier to build applications and so on. And we want to do this in a way that it's descriptive and complementing the existing IoT standards that are already out there. And the general idea is to look at what has worked in the World Wide Web and transfer this to the IoT space. And there to achieve this being complementary, we do not prescribe a full stack solution. This is how you have to build everything from now on. But we provide a set of building blocks that people can pick to solve existing problems that we have. And we already heard the keyword thing description a few times in the previous work. So this is something that can be picked up by any other ecosystem if they want to be accessible from other ecosystems across application domains and so on. What building blocks do we standardize at the moment? So if you look at the generic IoT system, it usually has a stack something like this. The central building block is this thing description. So overall, it's a JSON-based representation format that can describe instances of things through a formal interaction model. So it kind of improves over data models or information models that might be kind of implicit in the ecosystems, and gives some semantic meaning to it. So it's not only what data is provided, but also how do I get it, how do I modify it, and so on. Overall, you can think about the thing descriptions a bit like it's the index HTML for things, and this interaction model is built around the threefold of properties, actions, and events, which comes a bit from the programming model. So it should be easy for the way you build applications, or it's kind of from the programming abstractions because it's about building applications. The second building block are binding templates. So here the idea is that you look at a specific ecosystem. So for instance, OCF, you capture what are the specifics that you have to know about. So what, for instance, it uses co-op, okay, but it's not interoperable with lightweight M2M because you have to know which methods are used for specific interactions. You have to know what special headers or what special options have to go in there. And this we capture in these templates. And then if you want to write a thing description for a certain device from an ecosystem, you look at the template, this is what they do, this is how I describe it in a thing description, and can easily then provide information for such an ecosystem. And the last one is the scripting API. Think of this like the browser, so it's a runtime for applications. However, here the focus is not on the user interface, but on a faceless runtime where you can deploy IoT applications that do the automation for you. And we define kind of a small basic API that can be extended later with, for instance, the semantic API that Michael Costa mentioned earlier. Think of it, this is like the browser API, and on top you can build something like jQuery that has then all the fancy functionality. Overall, we also include security. So in the working group, we do not define any new security mechanisms or whatsoever, but we define some vocabulary so that we can specify what security mechanism is used and how is it configured, what parameters do I need to know about. So basically to make it easy to give all the information to a client so it becomes able to interact with an existing device. Good. Let's have a look at the timeline. So this picture already shows that we are quite progressed. So overall, the activity started around 2014. Interest group work started in 2015. The first 2 years were mainly spent on bringing the different people from the different backgrounds on the same page to get a common understanding what IoT is, what the Web of Things should be, how the technologies work, because we have people from many different domains, so a lot of embedded people from industrial standards and so on. So it took really some time to get some common understanding on all of this. And now we are almost to the end of the original charter. What we see here is that we have a slight delay about 3 months for the release of the candidate recommendations. And the reason is that we learned a lot recently, and there was a new working group chartered on JSON LD 1.1. So we started the work out with the version JSON LD 1.0, and then we got a lot of feedback that it feels a bit weird, and there are some things that application developers were not happy about. And most of these issues are addressed by the version 1.1, which is why in March, we decided to change to a new format of the thing description by adopting the JSON LD 1.1 processing. JSON LD 1.1 itself has the goals of being more idiomatic so that you can write a JSON document that looks like a human would write a JSON document, because before you had to use a lot of arrays. It solves some issues with default values so that if something is clear, you can just omit it, and by processing it, fill in basically these well-known defaults. And they have a new mechanism called framing to ease the serialization process and also provide some pre-processing of these documents. The implications of that are now that we could make the semantic annotations fully optional. So basically, you can now use thing descriptions without any knowledge about JSON LD. It just looks normal to you. Of course, you don't have then these semantic annotations in there, but you can still programmatically build something that can consume these thing description and do the right thing. This implicit knowledge is made explicit by using a specific media type for that. So we want to allocate application TD plus JSON for that. If you receive something with that, the JSON LD context, so that is the external file that gives meaning to all the keywords that you use in a JSON document, is derived from that media type. And so you don't need the special JSON LD keywords anymore. And we also loosen a bit the convention so that it feels more what web developers expected. Some other changes with the JSON LD 1.1 model, we could also make full compatibility with JSON schema. Before we used the terminology from that draft, but had a different syntax. Now those can actually be aligned so that you pick out the data schema definitions, feed them to a JSON schema validator, and it will work out of the box. So it's a nice combination of these different tool chains. And some other things are kind of housekeeping. So we looked into what are the terms that you actually need to make this productive. So one thing is that the ID, of course, needs to be mandatory if you want to do device management and so on, that there maybe should be some human readable identifier like a description so that if you do introspection of such a file that you understand what is going on. And we are collecting more, for instance, like versions that you want to give in a uniform format or created at and modified at and so on. In the slides that you can get from the meeting material, I don't know why it got that small. I think that was Carsten's tool chain. This is really bad now. Anyhow, go to the GitHub repository, there you find these slides, and then you can have a look and get a feeling how it changed. I hope overall everyone agrees that, yeah, this looks better now. So the right-hand side. Yeah, that's how I started out with the slides, so it's not as bad as this. Anyhow, so this is for the thing description, and there were also following up changes to the scripting API, and they turned out quite nicely because Now basically this software object of a thing that you would instantiate in your scripting environment is basically a JSON parse of the thing description, augmented with some functions that will do the network operations for you. So it's really easy from your script to do introspection and figure out the metadata of the thing itself, the interactions that are provided, and so on. Again, this is for you to study at home. Okay, so what is left to do until we release? For the thing description, there is one issue that came up pretty late, is that people wanted to have good support for these read or write multiple interactions that are quite common in industrial systems, but also quite often used in web UIs, for instance, when you want to display something, and of course all the fields should be populated. It's also a bit related to the trend of GraphQL, for instance, where you want to reduce round trips and get all the information you want to display at a time. We want to revisit the event model because some of the existing ecosystems have also input data on subscription, so that you, for instance, can install filters that you are notified only under certain conditions. And that was not possible at the moment. We had a very simplistic eventing model. And then it's about more housekeeping again, so finalize the model for the security vocabulary that I mentioned, and then align the links field that we use. So a thing description can link to other thing descriptions, saying that this thing is related to another one, that, for instance, there are some subcomponents, or that this light bulb is controlled by that controller. And that we can use similarly to JSON schema, the core links JSON structure directly in the thing description, so that again it really pulls together these different tools that we have and provides the full picture. One issue that we found this IETF was actually that the type for the media type given in web linking doesn't provide the full information that you would need for machine-to-machine communication, because the parameters that you, for instance, need for OSCore are not in there. So if you want to use this kind of information, for instance, especially for the forms where you have to construct the request, we might need a new attribute for this, which is then probably something along the lines content type, which would be similar to the CT attribute that was defined for the core content format number, which is called CT for historic reasons. Good, and then finish up with some IANA considerations. So for instance, I mentioned the media type we want to allocate for the thing description. Then for the scripting API, we want, of course, then to handle through the how to model this read-write multiple. We have to finalize the discovery calls, and what is so far open is to define how errors should be thrown, or what, how the error modeling within the API works. And for the binding templates, they are pretty far. What we saw is that we want to have definitely an extension point for the future, that we can have hypermedia controls starting from a thing description. So that means at the moment we just describe kind of these classic systems where you send a request and you will get an answer. But we see the need that if we want to continue here and really apply, for instance, these RESTful design guidelines that we also discuss in the research group here, there should be something that we, for instance, invoke an action and receive something back that guides us through a more complex process, so that the response again has some hypermedia controls that tell us, you have to wait that long, now you have to go there, or now you have to submit this form to go to the next step of the process. And for this we want to define just the extension point, because it actually goes beyond our original mission of just be describing, because this is something that doesn't really exist in existing ecosystems out there. So this is then probably something for the new recharted working group that will start, second quarter of next year, hopefully. And security and privacy. So there we have to set something up that we have an extensible security vocabulary, because we hope that the security mechanisms will evolve. And we also decided to start setting up a working group note on what security best practices, so to give more guideline for people who now want to build a system with this. But it's probably going to be like a living document, so it will be carried over to the next charter period. Something that was missing here because of the upload and font decrease process of Karsten, We also have to finalize the test cases and provide the test suite for our definitions here so that we can then actually go into the phase of the W3C process of once a candidate recommendation is there, you have to go through the test suites and have to prove that there are two independent implementations that basically have the full coverage and they are interoperable. Good. Thank you. If you have questions, send me an email. And most of this discussion is on GitHub anyway and quite open. Anyone awake? Questions? Everything fine? Good.
Good, thank you, Matthias. And as a reminder for everyone, if you're interested in hypermedia and semantics work, please join the WYSI calls and hackathons. There's always information on the Tingle Research mailing list and also in our GitHub on the logistics of them. Okay. Next.
Okay, so the next item is that we have these 5 impulse talks. Oscar, are you out there somewhere?
Yes, can you hear me? Yeah.
Yes, we can hear you, and I hope you can see the slides.
Yes, I can see the slides. Okay, so this is automated IoT security, and that's internet draft at a very early version. That is together with Torsten Damm from Google. So if you go to the next slide. Yeah, so we have this internet draft with overview of IoT security, and there are many issues over there. But the issue that we are trying to address here is a mismatch between basically the security capabilities of the devices when they are designed, manufactured, and deployed. Yeah, so it happens that when you manufacture a device, maybe it ends having some security protocols or settings. And when it's actually deployed, maybe the environment is completely different, and then different security protocols are required or settings. Might also be that there are vulnerabilities, and then you don't have a way to deal with those ones. Also, what the second bullet says is that, well, the requirements evolve over time, and we don't have means basically to adjust the security settings. So we put together this document, and then I will give you more details about the basic idea. But if you go to the next slide, then I even talk a bit more about the problems to make it more clear. Can you go to the next slide? Well, yeah, so we put here 3 problems. The first one is, well, if you have a device, a device that you might use in a home or in office or in the Department of Defense, obviously the security requirements are quite different. And even if you have a document that gives guidelines of security, it just happens that sometimes those guidelines are not followed. And then what do you do? The second one is that you have evolving threats. Some algorithms become insecure, and then what happens if you have a network when, in some of those devices you have an algorithm that is not completely secure? How can you make sure that that device was not compromised and not going to start stealing keys? Or that in some devices then there are bugs and then are used by an attacker to compromise the device. Or maybe also that if you have a home environment that the users change their preferences, maybe privacy-wise. So that's the second problem. And the third one is that, well, sometimes if you just manufacture devices and then you put them in the field with some pre-configuration, might be that also at that point of time there are also errors, could also happen. Maybe it's not known that the protocol needs to be disabled, or maybe a developer does not remove all the code that should be removed, or maybe the documentation does not state that a specific protocol is in it. So these are problems that, well, are talking just about a fixed setting, and the question is how to automate security to deal with this fixed setting. Can you go to the next slide? So in the draft, that again, as I said, is very first idea. We have three parts. The first one is we just give examples of security threats and mitigation strategies. Just thinking, well, if you have this threat, then it will be the type of mitigation strategy. Then the second part is we call it a security framework to try to include risk and vulnerability assessment processes in the life cycle of a device. So just think that instead of doing the risk assessment at the beginning when you are designing the product, that you can do the risk assessment in the specific environment where the device is deployed. I will explain this later. And the third part, you go to the next slide, is about security profiles, and that's something that was in the very in the first versions of the draft on security considerations for IoT. And the basic idea is that you can configure devices with different security profiles. And the basic idea is depending on the environment where the device is deployed, and depending on the risk assessment that you can perform in that specific environment, you can deploy a security profile, or depending on the environment. So this overview of the draft. Can you go to the next slide? Yeah. So there are two main protocols. The idea to develop those protocols, and we would like to get feedback on this. The first one is called Protocol for Automatic Security Configuration. And the basic idea is, well, if you look at the picture, the current practice is to perform a risk assessment or a privacy impact analysis when you are designing the product. And then later the thing is deployed, and maybe the security that you have there does not fit that specific environment. So the basic idea is to have a protocol that once the device has been deployed, you can actually perform risk assessment in the field. And then based on those that risk assessment, then you can deploy and configure a security profile for the smart objects in that environment. Next slide, please. So at very high level, the idea of this protocol that will be taking place exactly where the figure indicates is basically that the thing is going to publish a usage profile to the gateway, and the gateway might gather additional information about the thing. So for instance, expected interactions of the smart object with other devices in the deployment, and that might be by means of MAT files or port scan or accessing the different type of databases. And then the gateway, based on information of that device and based on information of which other devices are in that environment, based on information also of the specific preferences of users in that environment, can perform a risk assessment, basically determining potential threats for that device or on that device, and basically determines the security profile for that device, but also for other devices in the environment. And this is basically what next will perform. We'll deploy those security profiles on the devices in the environment. So this is basically the idea, right? So instead of just bringing to, for instance, your home a specific device with a specific configuration and not being able to do anything, putting basically the capabilities to adjust security after the deployment phase. So that's basically the idea in here. And then the second protocol that we have in mind, can you go to the next slide, please? It's called PAVA. So it's a protocol for automatic vulnerability assessment. And the current practice is, well, you have a smart home and maybe there is a vulnerability in a specific device, but you cannot do anything today, right? Or so the basic idea is to enable means standardized protocols to perform continuous vulnerability assessment, deployment, the location where the device is located. That can also enable incident response. So alert, for instance, the user, maybe a manufacturer, about a specific vulnerability in there. If you go to the next slide, So the very high level idea of this protocol that is even less described than the previous one in the net draft. So for sure, if yeah, this is interesting, there are lots of work to do. The thing could send standardized reports of potential vulnerabilities to the gateway, for instance, via syslog. The gateway can analyze also the reports and decide regarding the existence of a vulnerability. The gateway could also perform active analysis of vulnerabilities on the devices, could also analyze the network traffic in a much more active way, right? And everything obviously take into account the specific security profile or whether anything has changed. This basically, in the end, the idea is that it can enable updates of the security profiles in real time in case that something is detected. And the reporting could go towards the user, manufacturer, or basically the operator of the environment. So this is basically the idea of the protocol. And if you go to the next slide, and this is my last one. So we believe that this makes sense because of three things. The first one is for manufacturers, they don't need to decide which security mitigation are required design point. Obviously, it has also other constraints, right? Limitations. And you have to describe the usage, how the things will be used. For system operators, it minimizes operational cost while ensuring that the system remains secured at any moment. And it enables automation of security. And for the users, basically, they don't have to do anything. Well, maybe they have to include the preferences in the system for security, but otherwise, then the whole security configuration will be automated and also potential findings of vulnerabilities. Yeah, so this is the idea, and this time neither Dan, neither Torsten nor me could come, but well, if it's interesting, yeah, we might move forward with the ID, but only if this is interesting for the group and for everyone over there. So I'm done. Thank you. You have questions?
So, for me, this is a pretty interesting talk because it shows that you have some interesting interactions between some interesting interactions between the security procedures that we're using and the various forms of self-descriptions, third-party descriptions, signed third-party descriptions, whatever, and continuously changing information such as vulnerability assessments that are coming in. So I think that works very well together with the work that we are already doing in the context of mission, that security as a central component of the process.
This is Hannes. I have a question on the configuration. Oscar, if you have a microphone on, if you can mute it while someone...
Yes, and
okay, thanks.
So if we could go back to the configuration slide. One that shows the configuration. So it says that security profile configuration, and I was just wondering how would that look like? Probably it's described in a document which I haven't read, but I still need to do that. But how does that look as an example? I'm curious.
The system is called meet. Possibly you now have implemented that. Sorry, Oscar, did you get a question?
Yeah, I got the question. Can you hear me now? Yes. Well, I mean, it could be just based on access control rules, for instance, or it could also be based on which cipher suites you expect to use, or it could also be on the level of authentication that you require, or might be based on some splitting of the network. So there are many possibilities in there. For sure, we have not explored those. Ideas are welcome. But I hope that this gives you an idea, yeah, Hannes?
Okay. So I think we're running out of time, but I think we will revisit this, so I'm going to hand over to Mohammed now.
Yeah, so if you have ideas or comments, just send them in the mailing list, and yeah, hopefully comments come, and then we see from there.
Right, and there is a graph to look at, so I think we can have a useful discussion on this. Thank you. Thank you.
All right. Hi, this is Mohit. I'll be talking about how to enable network access for IoT devices from the cloud. We are in Montreal on 19th of July. So we have these IoT devices or appliances that we buy off the shelf, and you know, we bring them to our home or office, and they need internet access. Why do they need internet access? Well, it could be for two main reasons, either for reporting some data or for some service. So if the vendor or some third party provides some service, then you need access to the internet to connect to the cloud, but also for software updates. So that is a must. But these are off the shelf devices, so they don't have any clue about me as an owner that I'm buying them or where I'm going to install them. So they don't know about my home SSID or my work SSID and have no clue about that. So there's this two eternal problems of discovery and configuration. So this is something we also talk in the bootstrapping draft. Is how do I find the right SSID and how do I find the right server? I mean, there are many ways of doing this. Of course, the manufacturer could just hardcode a URL where it should connect and report its data, or from where it should get commands. But it's a problem that needs to be solved. So there's two parts. You need identifiers and credentials for first connecting to the network, which would give you access to the internet, and then you need to connect to the cloud from where you get your updates and probably get some commands. So of course we have solved this problem already for phones and laptops. You know, we enter SSID and a pre-shared key, or we enter certificates, or we enter a username and password for some online service. But bringing this to the devices that I had on the slide before, these kind of devices is challenging for very many reasons. But one reason is, of course, they have limited user interface. And then, you know, if at home I have like 2 or 3 laptops and phones right now connected, or even in office, I mean, we are just going to see many more of these devices, so scalability is also a challenge. And of course, you and I probably have some clue about SSID, secrets, passphrase, peering, but maybe not everyone has the same level of skill. So it should be possible for normal users to enable access for their IoT devices. And of course, we have a ton of link layers. So, I mean, we all have our favorite link layers. Some prefer Bluetooth, some like Wi-Fi, Zigbee. Other variations of 802.15.4 are out there as well. So there's two current solutions for doing this. One is manual configuration and key distribution. So this is just peering phone with a printer, or some simple pressing buttons, what some people would call as Wi-Fi unprotected setup. And then we have the more managed solutions such as radius, diameter, 802.1x, and all the vendor and enterprise certificates. So these are typically something that you will more see in a small office and enterprise deployments. But I think as the number of devices scale, this is something we might even move to home networks, because just having the same key when you have 100 devices at home won't work. So compromise of one device would kind of lead to the compromise of the whole network. So this is something that might happen in the future, that we'll have per device keys even in home Wi-Fi networks. So the next few slides that I have is just some example deployment models of how this could work. So we can never agree on what each vendor is going to use for authenticating their devices. But I'm hoping if they use some form of EAP method, I don't care whether it's TLS or it's PSK or whatever method they want to use. But the good thing about EAP is that it can make sure that there is per device credentials. So for those of you who are familiar with EAP and network access identifier and radius peering, what I would do is do a peering between the access point and the device vendor. And basically the idea would be that any authentication requests that come from vendor A will go to that vendor. That vendor would authenticate using several EAP request response messages and then enable internet access for this device. So, this is for one IoT device, but if you have a vendor B, so if I have a Philips light bulb, it could go to the Philips server, authenticate, and then enable internet access for that device. And again, the important point is the working group interested in some deployment scenarios like this? I don't think we have the energy to have one uniform EAP method for all of them because we will never be able to agree on that. So here's another deployment model which might happen in a more enterprise scenario. So instead of having, the AAA server in the access point, most enterprises already have a local AAA, and this local AAA can also be in the cloud. This is just an example. But then the peering would be more simpler. You will have a network administrator who would set up this peering. So the idea would be then to forward authentication requests from one vendor to that vendor's authentication service and another vendor to that vendor's authentication service, delegate this problem to them, and once this EAP session is complete, you at least have the internet access enabled. Is this something the working group would be interested in, just documenting the deployment, various deployment models that we have?
This is Hannes. Yeah, makes sense to me.
So are you willing to work with me a bit? Give reviews or write?
I could definitely do a review or contribute some text.
Cool.
I think I have some idea about that space.
Cool.
Thank you, Marie. That the basic idea kind of works, we know from a very large federation called EUROM that doesn't work at this meeting site for some reason, I don't know, but works everywhere else in the world. But of course, the main substance of EUROM is that you have all these contracts that build the federation. So maybe that's part of the examination, thinking about what is actually the legal framework that would make something like this work. I mean, if I'm a bad actor, I would build a radio server and offer internet access over EAP to people who pay me, and this is probably not something that should be possible in this space.
Mm-hmm. Yeah, we should definitely explore those authorization questions, but I think they would show up in other solutions as well. So those don't go away just because they change the name of the mechanism. I think they are universal.
So I think what I was suggesting is, how do you redirect authentication queries from one IoT device vendor to that vendor service? Hey, if you want to run a competing service and redirect your queries to this competing service, that's fine. So this would still allow that. I don't think we need to stop that. I'm all for it.
Yeah. Okay. What I was trying to say is that you might have some pretty surprising threat models when you look at it.
Okay, Börje Human, Ericsson. Just one question on when it comes to these devices and I buy one and then some small manufacturer goes out of business, what will happen with that device then?
I shouldn't have left this mic. This actually helps you in that case. So instead of now directing queries to that vendor, if you want to direct your queries to somewhere else, yeah, this is a big question, who would be interested in running such a service? But if there is some open source community that wants to do it, and we have seen it in two cases. So with Android, we had CyanogenMod, and with access points, we have OpenWRT. So we have seen two examples where consortiums come in and you can flash your devices. So I'm hoping if your manufacturer runs out and you don't want, or for some reason you don't want to use their authentication service, this deployment model will still allow you to redirect queries to some other service. So the important thing to note is the peering here. So you can peer it with some other service of your choice.
Thank you. René?
Good afternoon.
Hello. So Carsten asked me to elaborate a little bit on next steps in security, which is a little bit a very hard question to answer. But I try to focus really on crypto aspects because lots of people already talk about authorization issues. So, so this is how I see a device. It has a bunch of keys. It has some crypto algorithms on it. And then it has some functionality on top to invoke these functions and to manage it, and the security policies. And I'm sure there's lots of IETF groups that deal with some of these aspects. For example, ACE with some of the authorization issues. I want to focus on some of these elements of what should be on the device and where potentially we can still do better, or where maybe there's some danger that is lurking on the horizon. So the ideal functionality of these devices is that I think if we are in a kind of low resource environment, we would like to have a single function that executes each task, and we would like to minimize the overall implementation cost. So one thing we see right away there is that that may actually conflict the need for crypto agility, because crypto agility means that you may be able to switch one algorithm suite for another one, and it could conflict the single function for each task and the overall implementation cost. So I will go through some aspects of some things that I put in this big rectangular box over here. So first, the keys. I have not really seen too many or tinkered with too many real IoT devices, although I've done a little bit on some ML devices. And secure key storage is really an issue, I think. But let's see what kind of keys are on the device and whether we can still do something there. So first, so I had there like a capital K, which is like symmetric keys. Then I have like key pairs for a public key and a seed for a random number generator. So if you look at the IETF right now, then you see that keys cannot necessarily be reused for, let's say, doing ECDH, like the Hellman key agreement, and for doing signatures. And generally, if you look at lots of standards, you will also see like, oh, that's really forbidden. It's a bad practice to do things. But it's not, to my knowledge, it has not been properly analyzed. No matter whether we have done security research for 40 years or so. So I think if we could actually get away with one public key, we may be able to install one certificate on the device if we don't do raw public key. And save on the certificate cost and plow that money back into secure the implementation of the device. So I think we can still put a little bit of thought in there. I have some thoughts about it myself, but in this presentation I only wanted to focus on the questions. Then question like the second type of red items is the symmetric key material. Can we use one single symmetric key? It could be that the answer is yes to that question, but in generally it's really good to have some logical channel separation, and that's what symmetric keys do. But it is possible, also well known, how to kind of make a tree of keys or a key hierarchy. So I think there's not too much work that we can do there, although maybe our key hierarchy can be designed in a slightly more efficient way. And the third aspect is, do we need the randomness on a device? I think lots of IoT devices don't really have a proper source of randomness. Of course, Hannes will object because ARM has all superior TRNGs, right? So let's look at what kind of keys need randomness. So
I was just saying I just did recently a webinar on the RNG topic, and I just went to see how uncommon or common RNGs or hardware-based random number generators is in microcontroller. I took the MCU finder from ST Microelectronics, which allows an easy way to query all the devices, including for searching for different peripherals on those devices. And it turns out even ST Microelectronics alone has more than 400 low-end microcontrollers that have an RNG support in there, which I thought was pretty good. Of course, you can always pick the wrong hardware. And you can pick exactly the one that doesn't have what you need, but that would be a problem in any case. You can also pick one that just doesn't do what you want. And so I think we often say, oh, it doesn't have, but actually it does. And I haven't done the exercise of going through or many of the other vendors and to see what is whether SD is just an outlier or whether that's a common thing nowadays. And we also need to keep in mind that not all of the microcontrollers are used for internet-connected devices. Some of them have nothing to do with security at all. They may be just a motor controller or something, or a temperature sensor that doesn't connect to anything. It's just standalone thing. And so I think it's worthwhile to take a closer look at that topic.
Sure. So I'm happy to be pleasantly surprised. So this is just to point at certain areas. So so if you look at the long-term keys, for example, you want to embed a public key or a signing key on a device for firmware updates, then it could be that your source of randomness comes from outside the device. It could also be generated on the device itself, right? But in the end, we have to look at where the randomness should come from. Sometimes it's really needed on a kind of a short-term basis as well. For example, in the middle of the curve, development key exchange, and then something needs to be done on the device itself. But maybe it depends on the detail of the protocol, whether true randomness is required or whether we can do kind of a static on one side key agreement. So I think it's important there that we know what the purpose of the randomness is and what is really required on the device. And I would really be happy if it's always provided also in a cryptographically secure random number generator and not just some kind of noise derivation, right? And the search dash ahead there is what are the random number generator needs of the remainder of the device? Because I think there's lots of misconception by people that only keys need randomness. It could very well be that the implementation of AES also needs randomness, for example, for masking. Right? But so lots of these things probably don't have a home in IETF because IETF is not necessarily dealing with sidechain or countermeasures, but at least I think it was good to point it out. So now crypto functions, can we still do something there? So I had a very tiny draft in this LVIC group in March, and it was about the new shiny objects of IETF, which is NIST curves versus curve 25519. And they have been designed similarly with maximum incompatibility as an objective. But in fact, there's more commonality there. So it's possible, and that's actually a good thing, if you want to have crypto agility or more than one algorithm, that you can still use as many common building blocks as possible. So there you should also bear in mind that sometimes the crypto is compatible, but people choose a different bit or byte ordering. So there's lots of stuff going on that could make life miserable from an implementation perspective, also in the crypto world. But at least something can be done there potentially. Then I think we can still potentially save a little bit, since this is a research group, on crypto functionality in a symmetric key space. Often we need a hash function, and we need some kind of mode of operation of the cipher, which does, for example, an authentication tag or like a combination of encryption and authentication. So there, maybe it's possible that that there's some very nice, relatively new crypto based on the Ketzak family of protocols, which can be used to build all kind of these functionalities. And so we can potentially leverage one building block to build a hash function, to build an authenticated encryption function. So I think we can still do a little bit there. Personally, I think that there's still some option there to save a little bit. Although if I look at what's in the circle, then probably the public key block takes the most implementation cost. Then one little remark I had about, since some people in IETF talk a lot about it, like what happens if post-quantum happens? Does the world explode? Are small devices doomed? Right now, probably the threat is not that high, but obviously it's a good thing to work on it. I just want to point out that in the symmetric key space, just pumping up your key size to 256 bits instead of 128 bit is not enough. Because why do you need to do something in the post-quantum world? It's essentially due to, in the symmetric key space, it's due to the so-called Grover search algorithm, which reduces the size of the key space from, let's say, n to square root of n. So if you have an authentication tag, and I just looked it up in some specs, of 64-bit, in the post-quantum world, it's only 32-bit. So you may need to send longer packets over here, which I think will really anger a lot of people in this space. Right. Another implication is that if you can do post-quantum kind of search, then lots of details, if you dig into, for example, the AES round function, lots of distinguishers that the cryptanalysts are looking at to prove that AES is, for example, secure after X number of rounds, they don't really apply anymore because lots of distinguishers become more feasible potentially if you can apply a post-quantum search. So maybe some of these ciphers are less secure even if you double the key size. You may need more rounds. So lots of these questions have not been answered to my knowledge, although it's very hard as one person to follow everything. Then on the public key space, do we just need to ditch whatever we have in RSA or ECC and replace it by, let's say, a lattice-based scheme or a coding-based scheme? I know it's very popular and lots of people are advertising their wares. There's also lots of money going around there. But maybe you can just do something with a combination, let's say, ECC and a password. I know in the T2TRG group this week was an opaque proposal by Hugo Project. Maybe we can do something there. So I think we have to think a little bit outside of the box, especially because I think the last line still has some validity. If the classical threats are already ignored, why would you care about post-quantum? And I think that definitely applies to small devices. Then the last thing, you want to comment on it right now?
Yeah.
Okay, sure.
Hello, Kirsty Payne, NCSC. So I have a couple of comments on your post-quantum section that you were just talking about. So for AES 256, pretty standard. So subject to Grover's algorithm, that still would give you 1 to 8 bits of security. AES being quite lightweight, that's just something that I think would be fine. With public key crypto, you're saying thinking outside the box. And there's a conversation going on in IKE at the moment. It's like that IKE v1 is actually post-quantum resistant because they're pre-shared keys. So there's a proposal going through IPSEC at the moment to introduce that into version 2 as well, IKE v2, to add pre-shared keys to give that quantum resistance. So you don't need to be using large parameters or something, even something as simple as a PSK in there.
Sure. And it's met space.
Sure, and just generally, I think crypto agility is important, although I do take your point that if you have no security, classical cryptography is better than going the whole hog and going for post-quantum as well, but crypto agility just generally is quite good. If something is later found to be weak, to be able to replace that and drop that in is quite a useful property. Sorry, thanks.
Hi, Robin Wilson. I think you're right to at least re-examine the traditional assumptions about how PKI ought to work, and to question the rules that say what's forbidden and what it's acceptable to do. And I say that because several years ago when I was doing research into this, I spoke to a PKI vendor, and I kind of started the conversation by saying, people keep saying that, that this is going to be the year of PKI. And he said, I want to stop you there. 2 years ago was the year of PKI, and this was about, he was talking about 2008, 2009. He said in 2008 we shipped 1 billion public key pairs, and we expect to ship 1.5 billion in this year. And he was shipping them to mobile devices, and they didn't put the public keys in certificates. And I said, well, you're breaking all the rules. How can you do that? And he said, well, the thing we're using them for, it is not worth the extra 15 cents of embedding the key in a certificate, because this is to protect music tracks on a mobile device. You know, the lock tracks. Okay, so I just use that as an example because it shows how you should always revisit the assumptions. The next thing that research showed threw up was the mass deployment of public key of PKI was actually in fairly dumb devices, so embedded PKI, set-top boxes, smart modems, smart meters, cable modems. And the reason they broke some of the canonic rules was because if there was a problem with an installed key, you didn't bother about having a management interface to replace the key remotely. You replace the device or the smart card in the device. So again, an example of how it is valid to question the assumptions, even if at the end of that you come back and say, well, actually, no, the assumption still holds in this case. So when you're talking about these devices, there's that sort of cost to difficulty ratio you need to be aware of. When you say, for example, can you just dispense with a whole bunch of keys and use the same public key pair for both signing and encryption? Yeah, possibly breaks the rules. But on the other hand, if the device, if it causes a problem and your solution is to replace the device, who cares? If that's the most cost-effective way, fine, that might be it. So again, worth questioning the assumptions because sometimes the rules change. Does that make sense?
I think actually the answer should be you can, but there's some footnotes there. We can discuss it offline. So now I just want to, this is the last slide I have, just about key management. It was already mentioned what happens if something goes bad with the device. Are you just going to throw the device away? But it would be a little bit sad if it would be something embedded in an expensive car and you throw the car out. So, so the question is, how do you limit the impact of key compromise? And I know there's some work on short-lived certificates in IETF. I think it's also a topic that I don't want to be in a room when it's being discussed. But I think we should look at, if we care about small devices, about short-lived certificates at reduced cost. How can we do that? So obviously, if you have short-lived certificates and they're 15 cents a piece, and every month you have to buy one, then maybe it actually doesn't matter because your service provider charges you $100 a month. So, but for lots of applications, it does matter. But there are technical tricks available to reduce the cost of short-lived certificates. And just because it was somewhere in the bullet list of security what's next, I put in put ledger as a key repository help. So any people interested in blockchains and stuff like that, I think if there is a role to be played there is somehow, I don't want Bitcoin-oriented people to run away with the area, but I think it could help to have some kind of ledger functionality there. And then I just put as a few last items, I put like one of the topics that I think Mohit was also discussing, like how do you do provisioning, configuration, commissioning, and so on and so on. I think there's lots of work still to be done here, despite of it being kind of boring old crypto. I think it should become even more boring, but I think lots of our questions have to, and assumptions have to be reassessed. The last thing I wanted to mention is, what about privacy and control? I think Carsten, like 4 years ago, I was my last IETF meeting, I think before this one. I think Carsten mentioned like a Bluetooth toothbrush, which required to have internet access to operate. Well, that's my horror scenario of society. I think we should really be very clear who owns the data, and when we have a network, can be switched to another operator. And if I look at some of the internet graphs, like Anima and EST and whatever, lots of these things, I know we all have employers that are big corporations. As a consumer, I don't necessarily want things where the manufacturer can actually look over your shoulder all the time. So my note is technology is not neutral. So let's once in a while also think about ourselves not as an employee or whatever your role is, but also as a consumer, and we all read papers, so maybe we can do something useful there. So food for thought. That's it for now.
Thank you. So we had some questions in line already and are a little bit pressed for time. So Jenny is around if you have a question. So Dirk is next. Yeah.
You can have 5, don't worry.
Okay, hello. So the chairs kindly strong-armed convinced me to give you a little bit of an intuition about this cluster of edge computing, trust management, and privacy that Carsten alluded to earlier. So there is no JSON code in this presentation. We're working a bit in industrial IoT, so for network infrastructure, and so there are different ways how you can describe this environment. But one way to look at it is from a network perspective. So quite often we have something that we call the deterministic networking realm. So that's like Ethernet, TSN, these field bus systems, and the factory network. Something like an enterprise factory, a data center, and for larger corporations, you probably have some common enterprise cloud. So different protocols get used in these different realms. So as I mentioned, so we have like field bus protocols, TSN, in that production line environment. You have application layer frameworks to build applications to make data accessible. And so what's happening, so with like in the, say, grand vision of Industry 4.0 is that, well, you kind of restructure control applications, for example. So you move things like a PLC out of the production line directly and run it in the virtualized in the data center. And so the idea is that basically you install new equipment that comes with software, and the software runs at different levels in this system. So you could say, when doing this, your factory becomes like a multi-tenant environment. So you have different functions, physical functions, but software functions, and they are sharing one infrastructure, and that wants to be managed. So earlier in a previous meeting, so colleagues from China Mobile presented the idea of beyond edge computing. So say a distributed system also of like multi-tenant components that are plugged in together for different verticals, and so with the proposition to have common infrastructure elements across these verticals that allow running this, managing this, and monitoring this, and so on. So another say thought that we often discuss in IC Energy is data logistics. So so sometimes you hear like scenarios like autonomous driving, for example, terabytes of data get generated. It needs to be stored for forensic reasons, but it can also be made accessible and eventually is accessed from outside a car. So you have an environment where data is generated. People want to access it at some point. If you think about constrained devices, they may not have the storage to provide this data for a longer time. So you could think about a custodian system where I drop my data and it's maybe stored or made available on my behalf. You probably have, in IoT, we often discuss things like data aggregation, data fusioning. So we are moving a bit into a system where we, have some processing, some computation on data. And the question is, so what is actually a good approach for that? So obviously there are different ways to deal with computation in a network. So in the, say, telco environment, there are well-established approaches like visual network function virtualization, NFV, which is like basically automating VM deployment. So that's probably not quite what we need for the applications I mentioned. So what I'm thinking more about is, say, networked computation, so more fine granular, more distributed systems. And so you look a bit into the, say, protocols that are currently used, especially in the industrial IoT environment. You may have heard of things like OPC-UA, so Open Platform for Communication Unified Architecture. That is a technology that came out of, say, the object linking world. It's basically a client-server technology that allows you to access named data on a server. And you could use it to connect, for example, servers and then also instrument some computation. But so as you can easily see, it's not the ideal technology to implement or to realize distributed computing in a network. So it's more like a data kiosk thing. And so connecting these things with like back-to-back server client configurations is not really scalable. So taking a step back, so what if we could actually leverage modern technology instead? So we have all these advances in virtualization, like unikernels and so on. Mobile code is actually more realistic these days with all these micro-scripting environment. We have things like trusted execution environments. And also in the protocol world, we have things like ICN, name function networking, and so Carsten also mentioned earlier. So as things get more distributed, combined, composed, we can also leverage stuff like decentralized task management. And so we're working on an approach that where we think, maybe let's think about if you really want to enable distributed computing, what does it mean for networking? So maybe do we have to reinvent networking or at least incorporate some elements into our protocols that enable so this way of distributed computing. Okay. So what we're working on, so the working title for this is Compute First Networking. We want to leverage this increasing availability of computation at different scales. So virtualization, unikernels, mobile code, where we think, okay, let's do distributed computing as a first order principle. And okay, I talked about industrial IoT. There could be one application, but you may have heard of the other applications like in data centers where putting a certain piece of logic in a topologically convenient place can really speed up your whole distributed application by quite a bit. So this would be like on the other spectrum of distributed computing that we're looking at. Of course, so Carsten mentioned active networking. If you do this, I mean, you can really fall hard, and there are many mistakes you can make. So just one notion that I want to kind of give you here. So we have done these things a lot with overlays in the past, and I mean, so what we're kind of proposing here is to maybe move a bit away from the overlay approach, but put more functionality into a data plane to enable distributed computing. So there's probably some good balance that you have to find. So overlays, of course, enable you to come up with new functionality that is kind of decoupled from the network, which could also be a feature. So if you now integrate this more, this could be more efficient, but it could also, limit you and exclude maybe future applications we cannot really think about today. So let me skip these details. You will have that in the material. So just to give you two examples, what people have been doing so far. This is an example from the ICN research community. So colleagues of mine at UCL built an approach that they call name function as a service. So it's basically the idea you treat Unicode images as, say, ICN data objects, and you can express computation by, composing like function calls that use those names, and the system is, fetching those objects, instantiating them, so on at, say, convenient or like selected execution platforms. And so if you kind of scale up these systems, and so you think about this multi-tenancy idea, you probably want to use your resources efficiently. So maybe you have an economic model that basically allows you to, say, assign a cost to computation. So the next step they did is they developed an approach called SPOC, secured payments for offloading computation. And so that's basically a distributed-based approach where I can kind of, have a smart contract with somebody who executes my computation and is kind of paid for that. And so that the smart contracts ensure that I can, trust that my execution is executed, my program is executed, and so the platform can trust that it's actually paid in the end. So, and that's just an intuition. So why trust management in this particular environment would be quite important. So you put you compose systems from with functions from different vendors, different applications. They don't really know much about each other, but they want to cooperate. And you want to have a system where I can decide, okay, I trust this function but not this one, without necessarily being able to use a centralized trust system for that. And so this is like one specific example why we are looking into this trust management problem. So, so our thinking is, so we're talking a lot about edge computing, fog computing, and so on. But if we're honest, there is no really, say, one accepted common basis for that. I mean, there are different white papers, some projects, and so on. But so to me, there really seems a need for a more principled approach, especially if you think about this multi-tenant and really distributed idea. So if you do this, okay, you have to think about, so what is, say, my innovation spectrum in this space? So if so what is the good balance between a general purpose system and a highly efficient system? And so from, say, for the ICN folks, the question is, to what level should we actually empower the data plane to support, finding functions, optimizing core graphs, and so on? And to what extent should we leave this to orchestration perhaps? And so finally, I think really crucial is what are the requirements for trust management that enable, the security in the system. So how can I trust the platforms to generate the data and the mobile code that they actually run on the systems? So if you're more interested in these trust management questions, please come to our meeting tomorrow at the DINRG meeting. Thanks.
Yeah, thank you, Dirk. So if you go to OWIG tomorrow to learn about René's newest work, you can, before that, go to DINRG, so that will be interesting, probably then unfortunately we're out of time. But I would just like to point you to the last talk, which I now cannot give. But maybe you just want to go to one of the Wishy phone calls because there we discuss things like this. So there is probably a good idea to think about semantics for security and also about security for semantics. And you can get a preview with the slides that are on the data tracker. So thank you everybody for coming, and see you in Bangkok and or in the various phone calls we have in between. And who has the blue sheets?